All right, so opposite angles. What do you know about opposite angles of a parallelogram? They're congruent. So if this angle is 70, then what's this one have to be? It's 70. And what do you know about consecutive angles in a parallelogram? They equal 180. That means that this whole angle plus 70 should equal 180. Do you guys agree with that? But that whole angle at the top is comprised of how many total angles? 2. All right? So that means that this whole angle, if I were to add them together, that total is what? If this one's 70, then this one has to be how much? 110. The whole thing is 110 degrees. But I don't need the whole thing, do I? I only need how many pieces? I need each little piece. Now, go back to your information from yesterday about a rhombus. What do the diagonals of a rhombus do? They do 2 things. They bisect each angle, and then they are what to each other? They're perpendicular to each other. So that means if this whole thing is 110, how am I going to find each of those little pieces? 110 divided by 2 is 55. So that means that one's 55, that one's 55. What are these then? 55 and 55. How can I go back and double check? Well, I see 2 triangles. Do you? What's the sum of the interior angles of every single triangle? 180. Add 55 plus 55 plus 70. Do we get 180? Yes, we do. Okay? Folks, that's all you had to do. I don't even care about those numbers. I don't care about those numbers. I care about the numbers you put into those angles. What are the angle measures? Okay? Do you have questions on 23? That's how I would have done tomorrow. What's tomorrow? Thursday? Okay. On Thursday, which is tomorrow, you are going to have a quiz on the following things. You have to be able to write out the 5 properties of a parallelogram. Oh, no. No. You're going to write those from scratch. There will be no prompting like I prompted you the last time to tell me about opposite sides and opposite angles and all that mess, okay? But after those 5 properties, then you will have to fill in the blanks. You got to know the properties of a rectangle, a rhombus, and a square. And then you're going to have to work some of these application problems. And that's all we're going to do today. Okay, full time, we're working on these. We're going to work for a pretty good time on a worksheet together. We're going to do one together, and then I'm going to turn you loose, and you're going to work on your own. And folks, I've told you from the get-go, you're going to have there will be times you're going to take stuff home and you're going to work on it. Now's when it counts. Okay, it really does count. You know, if you go to a practice and you shooting threes all day long in practice, does it matter? When do you need to be making threes? During a game. It don't matter what you can do at practice. If you can't execute during a game, it doesn't matter. I need you to start executing for me. Not like killing people, but I need you to step up your game, okay? Whatever it takes is what you got to do. Whatever it takes, okay? So you need to be ready for these tomorrow. And folks, don't come in here. It is what it is. Grades are finished. I will show you your grades when we start. Will you please remind me? When you start working on your worksheet on your own, will you please remind me of that, and I will show you your grades. Because some of you are on a fence of, ooh, this is not good. Okay? Yeah, you'll have plenty of time to sleep. All right, see you in a little bit. Apply those properties, okay? Are you ready? So let's look at this worksheet that I have. All right, so let's look at this. What? You're so cool. Here we go. What up, Cody? Joseph, you all right? Okay. Here we go. Guys, you may need your calculator. It should already be out though. Shh. This is all being recorded. Joseph and Zoe fighting like their brother and sister. Stop it. Okay, stop it. That's okay. It's being recorded. It's going to be on YouTube forever with my 1 million views. Why are you laughing? I don't know, don't care, but it's all this information is there for you if you need it. I will set it up so that you cannot comment on it. That's true. All right. It says use the properties to solve for the whatever. Read the sentence at the top. Okay. Kale, don't laugh. LMNO is a rectangle. That's important to us. We have to know all the properties of a rectangle. And if you forget, hey, look at the top of the worksheet. Now, it's got a whole bunch of stuff that we've got to fill in together. And folks, you've got to be engaged in this. Do not just sit there and wait for me to write something on the board. I need for you to think about this. Think about what values have to go in certain places. Now, it says if LM is 16, folks, mark up your picture. MN is 12. Mark that side. Angle 1 is 60 degrees. Find the following. Okay? Now, I don't care of the order that it's asking me for these things. I just want to start filling things in. I know that this is a rectangle. What are the things I know? What, Jade, go? The sides are parallel and the sides are opposite sides are also what? They're also congruent. So that means if LM is 16, everybody, what is ON? It's 16. Fill it in here on the picture. Fill it in here in the blank. What else is easily figured out, Kale? OL is? It's congruent to MN, so if MN is 12, LO is whatever. Hello. Think about it. Hello. What about LN? That's what I was referencing, you ding-dongs. Justin, go ahead. What'd you say? No. I got to find that diagonal. Okay, let's keep looking. I'm going to kind of leave that diagonal alone, that LN. Are y'all okay with that? You know what? Angle 4 would be 60 degrees. Do you guys agree with him? Absolutely. Angle 4 is 60 degrees. Why is 2 and 3 30? 60 minus 60 from 90 is 30. Exactly. We talked about this yesterday. What kind of triangles are we looking at here, y'all? They are isosceles triangles. I've got two pairs. This triangle here at the top, this green triangle, is congruent to this triangle at the bottom. So that means that if angle 2 is 30 degrees, then what is this angle right here? And that one's 30, and the other one is 30 as well, isn't it? How in the world am I going to figure angle X. Oh, Jade, listen at her. Jade, you said 180 because you're focusing on that triangle, aren't you? Okay? If that triangle is 180 and I have two 30-degree angles, I'm going to take 30 away from it twice. What's that going to leave me with? 120. All right, check this out. So now I've got 120 degrees here. Do I know another angle? Straight down because of vertical angles. I know two more angles. And that's going all the way back to the very first month. What's that? Look at what she's doing with her a linear pair. The rainbow. I can say, okay, I know that linear pair is equal to how much? 180. So 180 minus 120 is? That's right, 60. 60. What's the angle across from it? Why? Vertical angles. Have I looked at any of this over here yet? I don't care about it yet. I do not care about it yet. All right, I've got everything in there. Let's see. I still don't have LN. I still don't have LX. LON. Where's that angle? L, start at L, O, N. That's 90 degrees because this is what kind of figure? Rectangle. What's angle 2? Dennis, is it 30? Yeah, how'd you know that? Okay. How about OX? Do I know the length of OX? Not yet, but I'm going to figure it out. Do I know the measure of angle 3? What is it? 30 degrees. Do I know the measure of angle 4? 60 degrees. Now we got to think. Okay. I'm going to redraw this because it's too much stuff in my picture. I got O, L, M and N, and X in the middle. And I know that LO is 12. And I know that LM is 16. Now, what kind of triangles fit within that rectangle, Daniel? What kind of triangle is that I've highlighted in red? It's a right triangle because we know that this rectangle has 4 right angles. You guys agree with that? All right, what are you thinking?
Well, I was thinking like the triangle, the one with the 12 on it.
Yeah.
Since all 3 measures of that are 60, doesn't that mean all the sides are also equal lateral?
Oh.
All,
Oh, look at you. Look at you. Go on, Daniel. Look at this. I hadn't even realized that. Look at what he's saying. We know that those two angles are 60, right? All right, so he wants to focus on, let me move this up. He wants to focus on this right here. You guys see that blue triangle? Okay, what's this angle right there? 60 degrees. Okay, let's think about it. Let me back that up. 60 degrees. I'll buy that. Focus on the blue triangle only. Smarty McFarty. What kind of triangle has 3 60-degree angles? An equiangular, which is also called an equilateral, which means all 3 sides are congruent. Yes? What's segment MN? So if MN is 12, folks, what is segment XN? 12. What is segment XM? What is segment LX? Why? They do bisect each other. Why do the diagonals bisect each other? Because this is a rectangle or because it's really a parallelogram? Because it's a parallelogram. Why also Do the pieces. What do we know about the rectangles big, the whole diagonals in a rectangle? This is one of those properties you've got to study tonight. What do you know about? Think about it, y'all. Look at if you could envision the way I have my arms crossed, and you can envision a rectangle around. Can y'all envision that rectangle? You see it? Do you really see it, or are you just telling me what I want to hear? Don't lie to me. Would you lie to me? You lying to me now? Promise. Don't lie. Okay. Here we go. Look at my diagonals. What do you know about my diagonals? They are bisecting each other, but look at the diagonals as a whole. What do you know about those diagonals? What? Yeah. Not what I'm looking for. Patrick, what are they? They're congruent. Look, from my fingertips to my elbows, unless something's wrong with me, they better be what? They better be congruent, right? Think about it. That's why if the whole thing is congruent to the other whole thing, diagonal, then each of the little pieces are going to be all congruent, right? So if LX is 12 and XM is 12, hold that thought. If LX, MX, NX are all 12, what is OX? 12 as well. Are all of my little pieces congruent? Yes. Now, Justin, what were you saying? Why would LN be 24? Somebody explain that. You're right, but why, Patrick?
Because one half, I think there's another half, they're both joined together in one, so they both are added up to equal sum of the angles.
Which is? 12 and 12 is? 24. What Justin said. Very good. It is 24. LN is 24. Good, Justin. Good explanation, Patrick. What is LX? It's there. 12. What is OX? 12. Folks, what do you think about that? Easy. Is it easier now than it was? I hope so. I hope so. It ought to be getting easier with every problem you do. Okay? Let's look at the next one. Any questions at all? Do you see how you pick this apart? Do I really go in order of what it's asking? Not at all. Not at all. But, I wonder why do you think that is? I know. I was trying. You better wipe your nose there, Cody. Wipe that. You trying to get on the teacher's good side? No, I said you trying to get on the teacher's good side. Wipe that nose off. All right, here we go. Look at this next one. Yes, sir. 12. Because. Stop talking. See this right here? Do you see this equilateral triangle? We knew that this MN was 12. And because all of the sides of that triangle are congruent, that means that all three of those pieces are 12. And that's how I was able to go from there. Hey, folks, just throwing this out there. I was focusing. This is the thing that I like about geometry and trig. Because I can see something one way, and Daniel saw it another way. Daniel actually saw it the easier of the two ways. I was focused on what kind of a triangle? A right triangle. I was focused on a right triangle where one leg was 12 and the other leg was 16, and I wanted to find the hypotenuse, which was OM. How could I do that? What theorem that only deals with right triangles could I have used to find that one length OM? Think. Say it again, Amber. Which is called what? Pythagorean theorem. I was going by way of the Pythagorean theorem, which I can do, and I'd get the same answer. Daniel went way easier. Attaboy. Very good, Daniel. Very good. Any other questions on this one? All right, here we go. What kind of figure is this one? It's a rhombus. All right, first and foremost, what do we know about a rhombus? It is a parallelogram. That's the first thing you need to know, that it's a parallelogram. So that means it's got all the 5 properties of a parallelogram. The second thing you have to know about a rhombus by its definition is what? The diagonals are perpendicular. They do bisect, but more importantly, what do you know about every side in a rhombus? That's right. This is going to be a great video to watch. It says WX is 4. Start filling things in, folks. WXY. WXY. That whole thing is 60 degrees. The whole thing is 60. And we got to find the following. Woo, we're not giving a whole lot of information here, are we? Dang. All sides are 4. Why? Because they're all congruent, because it's a rhombus. Why? 60 divided by 2, which is 30 and 30. You better be writing this down and paying attention to what's going on. What else do you know? Say what, Kevin? What did?
Angle 1 and 2 put together are...
Oh, now we know. Say what?
Angle 1 and 2 put together are...
Angles 1 and 2 put together. How do you know that?
It's angle 60 minus 60.
That's exactly right. That's exactly right. Do you guys agree with that? Mm-hmm. Hey, you right on, Daniel. Very good. All right, now I want you to see something. Now you got to back up. All right, kind of back up and look at this. Did he use any properties from a rhombus? No, he used every property from a what? From a parallelogram. Okay? He used every property from a parallelogram. Nothing from a rhombus. Now I'm going to use one from a rhombus. I want you to step back and I want you to think about that right there. What do you know about the diagonals in a rhombus? They form 4 right angles on the interior of that rhombus. So that means 4 in this picture, yes. Is it true for every rhombus? No. Okay? In this picture. That's cool, ain't it? That's cool. Now, think about it. We've got to figure this out. Now I got right triangles again. Ding, ding, ding. I may have to use what theorem? That I wanted to use a while ago, but we didn't end up using it. Pythagorean theorem. We may have to use it. So we have to be ready to use it. Okay? I've also got a 30, 60, 90 triangle in there, don't I? Justin, what you looking at? No, can't do the same thing on this one because it's a rhombus. It's not a rectangle. Okay? Now, I can't do it that way. Now I've got to focus on a 30, 60, 90 triangle, folks. Look, I want you to draw the 30, 60, 90 triangle. I got 60, 30. What I have taken out is triangle WXO. That's what I'm looking at. Specifically, that's what I'm looking at. From the original picture, what other type of information can I put into my little triangle here? Say it again. It's 90 degrees. I got it marked here, right, with the box. Look up there, though. WX is 4, isn't it? Remember when we went over special right triangles? This is when we went over 45, 45, 90, and 30, 60, 90 triangles. Okay? I have the hypotenuse of this triangle is 4. What's the length? First of all, where is the short leg? Is it WO or OX, the short leg of that triangle? What is it, Summer? The short leg? Why? It's opposite the 30 degrees. Now listen. The short leg, if the hypotenuse is 4, what's the length of the short leg? Who said 2? 2. What's the length of the long leg? Come on, folks. Remember this. Say it again, Summer. 2√3. Very good. Good. All right, now, put that information in your big triangle, or your big rhombus. I've got WO is 2. If WO is 2, is there another piece on that rhombus that is also 2? OY will be 2. OX is 2√3. Ooh, better be careful right here. What other piece is 2√3? ZO. All right, now let's start filling things in. We put a whole bunch of information in there. Whole bunch of information. All right, so here we go. I've got XY. XY is 4. You guys agree with that? Angle ZWX. 120. We found that out very early on. Angle 1. Half of 120 is 60. You guys cool with this so far? What about angle 2? It's 60. How about angle 3? How about angle 4? Okay. All right, now we got to be careful. WO, OX, and WY. How come? 2 plus 2 is 4. What do you think? I hope so. I hope so. You need to figure this out. And I'm going to tell you what. Are you going to be able to just sit and absorb it and just say, I got it? Very few people can. Most of us have to what? We got to do a little practice, don't we? We got to practice a little. Let's look at the next one. Any questions on this one? Don't forget about your Pythagorean theorem. Don't forget about special right triangles, your 45, 45, 90. Don't forget about your 30, 60, 90 triangles, okay? Be prepared for those. Last one. What kind of figure is this one? It's a square. Folks, not a whole lot we can do about a square. The square is the supreme pizza of special parallelograms. Why do you think I call it that? Because it's the most. It's got it all. I said the square, and I totally stole this from Ms. Harrell, okay? So I have to give her props for this. The parallelogram is like a cheese pizza. Why? No, cheese. It's the base, it's the foundation for every pizza, isn't it? If you're eating a red pizza, one with red sauce, then it's the basis of every pizza, isn't it? Okay, so isn't a parallelogram the basis of all other special quadrilaterals? So it's the cheese pizza. You throw a little pepperoni on there, and then we've got the rectangle. Okay? Throw some mushrooms on there, you've got a rhombus. But if you throw everything on there, everything, all of the properties that you know, the properties of the parallelogram, the properties of the rectangle, the properties of the rhombus, then what figure do we have? What quadrilateral do we have? We've got the square, which is our supreme pizza. That's the pizza with everything. Okay? Now, this is easy. The angle measures never change in this. It's easy. Yes, sir. You have to know the properties. You have to know the definitions. If you see a four-sided figure that says has four right angles, you have to know like that it's a rectangle. If you see or are told a quadrilateral has four congruent sides, you have to know immediately that it's a what? A rhombus. That's what I'm going to ask you tomorrow. If it has a quadrilateral with four congruent sides and four congruent angles, then it's going to be a what? What? It's a square. Yeah, it is slanted. It's like a rectangle that's been shoved on the top, doesn't it? Like the base stayed put, but the top. Or that wasn't recorded. Square. It says EF is 10. This is easy. What other sides are 10? All the other sides. How about the diagonals? Are they? Are they? What kind of triangle do you have? It's a right triangle, isn't it? And it is a right isosceles triangle. So, folks, how am I going to find that length of that diagonal? It's a right triangle. I have two sides given. How am I going to find the what? Pythagorean theorem. Or special right triangle. Let's go with Pythagorean. Yeah. Say what? Why? You jumping back to the angles, Justin? Which other angles are 45 in a square? All of them. All of them are 45 each. In the corners. And in the middle, it's what? They're 90-degree angles. Squares are easy, aren't they? Bring on the squares, right? But how are we going to find the hypotenuse? We're going to use Pythagorean theorem. Check this out. Hypotenuse squared is equal to leg squared plus leg squared. What am I trying to figure out? I'm trying to figure out the hypotenuse. So that's my x. What's the length of one of the legs? 10. What's the length of the other leg? So I've got x squared is equal to 10 squared is 100. 10 squared is 100. I get x squared is equal to how much? 200. What now? Square root of both sides. What's the highest? I'm not talking about decimals now. What's the highest perfect square that divides into 200? This one's easy, y'all. It did 100 times 2. What's the square root of 100? Where does it go? What about the 2? Stays inside. So that means that hypotenuse is 10 root 2. Right here, 10 root 2. Which means that the length of HF is also what length? 10 root 2. Now let's go back and fill things in, sorry. FG. Got to find it. What's the length of FG, Kevin? 10. Alexis, the measure of angle EFG. How much? I just didn't hear you. 90, yeah. I just can't hear you. EG. Michael, what's the length of EG? Michael, what you get for EG? (10√2). Jade, what's EI? Ooh, where is the I? The I's in the middle. Ooh, Jade, how are we going to figure this one out? Oh. I got to take 10√2 and divide it by 2, don't I? Because not only are my, what are these? Diagonals. My diagonals are congruent, but they also bisect each other. What is 10√2 divided by 2? 5√2. 5√2. Yeah. Because of the Pythagorean theorem, we had to use Pythagorean theorem to solve for that. For EG. That's what we just solved for right here. Okay? It's a 45, 45, 90 triangle. It's a right triangle. I had 2 legs given, so I was able to use that. How about IF? One more time. 5√2. What about angle EIF? 90 degrees. Very good. How about angle 1? How about 3? And then the measure of HF. HF, 10√2 again. What's going to be the most difficult part of finding, what's the most difficult piece to find in a square? The diagonals. Because you're going to have to use what? Pythagorean theorem, or you're going to have to remember your 45, 45, 90 triangles. Okay? So, get ready for that. Okay? Questions at all? What are we going to do with this? This is going in your notes for today. So today is the 17th. Okay? Worksheet side that says reteaching. Okay? This page, and it's the first side according to the holes on the left. I want you to do 1 through 6. And folks, put your answers in the picture. If that means you have to draw arrows, then you draw arrows. I do not want you to list the measure of angle 1 equals blank. The measure of angle 2 equals blank. Don't do that. I want to see the picture. It's going to be easier on you. Flip that page over. And it says practice 6-4. I want you to do 1 through 6. 10, 12, and 14 through 16. Now, you're going to turn this in. It's for grade. Some of you, bless you, will finish it before you leave today. Some of you will not, and you need to turn it in tomorrow, okay? But I have to have you do this in pencil, not marker. Comprende? Any questions on this? Do not, all right, look at 1 through 6 on this side. I want the angle measures only. Because it says, choose the best name and then find the measures of the numbered angles. No, I ain't worried about no name. Just find the angle measures, okay? 10 and 12 have to do with what kind of figures? Rectangles, and there are no pictures drawn. So folks, for 10 and 12, you might want to draw this figure right here, HIJK, and I think it's talking about some diagonals there, HJ and IK. That's exactly what it's talking about. For 14, 15, and 16, you're talking about rhombus, and I only want the angle measures there, okay? Angle measures only. Do you understand what's needed? What is required? Yes? All right. Do not ask me. Do not ask each other. Get on this. You've got to do it on your own on SOL day. Let's don't refer or rely on Ms. Perry, okay? Can you use your notes? Yes. Can you use your book? Yes. You cannot use each other and you cannot use me. Do you understand? Get on it. Yes, sir.